sketch the graph of y is equal to 3 times the square root of x minus 5. The way I'm going to do this is I'm going to compare this function to the base function, just the square root of x, and note the transformations, the 3 and the negative 5. If we take a look at the general form for transformations, we have our a value, which is the vertical stretch, that's equal to 3. That's the number out front. And also our k value, which is the vertical shift, is negative 5. And so we have those two values, a equals 3, so vertical, because it's greater than 1, it means we're stretching it. We're stretching it vertically by a factor of 3. And because our k is negative 5, again, it's our vertical shift, so that's, and because it's negative, it's 5 units down. And so if we take a look at these table of values, what I did is I got 4 points on the original function, y is equal to square root of x, just by plugging in x values that are perfect squares. So square root of 0 is 0, 1 is 1, square root of 4 is 2, square root of 9 is 3. And what I'm going to do is actually the x coordinate doesn't change, but the y coordinate, again, because it's vertical expansion, is 3 times the y coordinate. Again, whatever the y coordinate is multiplied by 3. And I'm going to subtract 5 because of the 5 units down. And so all the x values all stay the same, 0, 1, 4, 9. But I'm going to plug in 0 for y, then I'm going to plug in 1 for y, and I'm going to plug in 2 for y, and then 3 for y. And that's going to give me my 4 points right here. And so if you plot these 4 points, you're going to get something like this as your graph. And so as for the domain, well, it's simple. The square root cannot be negative, and so x has to be greater than or equal to 0. And so in other words, you can also tell from the graph, actually, that x has to go from 0 to positive infinity. And so that's our domain, from 0 to positive infinity. As for our range, it goes from negative 5 up. In other words, from negative 5 to infinity. Also, graphically, here I graphed the two functions in orange and purple. Notice the transform function in purple, it's been stretched vertically. So in other words, it's taller, so to speak. Also, because of that vertical shift 5 units down, notice how it starts out further down.